In this video, we're going to be talking about how to find the length of a segment, or in other words, how can we find the distance between 2 points on a number line. There's actually three types of segments that we can have. We can have a horizontal segment, like segment AB here. It's a little light here in the video, but on your notes, hopefully it looks a little better. You could have a vertical segment, like for example from A to D. And we can have a C to D, I'm sorry, that's what's on your paper. We can have a diagonal segment. That could be like E to F. So we're going to talk about how to find the distance between all three of those different types of segments. First of all, we need to understand that distance is always a positive value. Keep that in mind. The way in math that we make sure that something is positive is we can use these symbols called absolute value. They look like these little vertical bars that are hugging some value. Anything that's inside those vertical bars is going to come out positive. Be careful. A common mistake is to think that it's the opposite of what you see. No, absolute value always makes something positive. So if a value inside those absolute value bars is negative, we make it positive. However, if it was positive to begin with, keep it positive. Absolute value just makes it positive or keeps a value positive. So we're going to use that to make sure that our distance is always positive. The way that we find a horizontal distance, well, if we look up here at our example, notice that the height is not changing between these 2 points, so the y value is not changing, so there's no reason to look at the y value. What is changing is the x value at these two spots. So what is the difference here between this x value of -4 and b's x value of 3? What's that length or distance on a number line? Well, we know we can count, but at this level in math, we're going to have to use some sort of math to prove, and we can use our counting method to check our answer. So, in math, we use the word difference, which means subtraction. So a difference between 2 points means that we're going to subtract. And if it's horizontal, we're going to subtract the x value. So we have an x value of -4, an x value of 3. Let's do -4 minus 3. That gives us -7. Again, because it's a distance that we're talking about, we'll use those absolute values to make it +7. One symbol that we use in geometry to describe a distance is we just put those two endpoints together without anything written on top. That means the distance between those 2 points. That's how we read it. So saying find AB is really read as find the distance between A and B. So this represents the distance between A and B is 7. In other words, the length of segment AB. So a little bit different there in that we don't have that segment symbol. When we have the segment symbol, that means we're talking about this physical segment right here. All right, maybe you're asking, does it matter which order I subtract in? What if I was looking at it from right to left? Well, let's check it. Let's see if we do 3 minus -4. 3 minus -4 becomes 3 plus 4, and we get +7. No use for the absolute value there because it gave us a positive distance to begin with. So no, it doesn't matter what order you subtract in inside absolute values because it will make the answer the same positive value afterwards. All right, let's do the exact same thing, but this time we're going to find a vertical distance. So we're going to find the length of segment CD, and this time we're just going to change it to be subtracting the y values because we have a vertical line. So the vertical values are the ones that are changing. Notice that the x value stays the same for both of them. So let's only focus on the y's and subtract the y's. We got a y value here of -1 and a y value here of -4. So if I do -1 minus -4, that turns into -1 plus 4, which gives me 3. I can keep it as +3. So the distance between C and D is this symbol. The distance between C and D, that's how it's represented. And it is 3 units, and that's the length of segment CD. Does it matter what order you subtract in for vertical values? No, in the same way it wasn't a problem when we did the horizontal ones. So we can try it out. We can do -4 minus -1. Just flip it. That gives us -4 plus 1, which is -3, but because it's a distance, we make it positive, so we get the exact same length there. Now that you can prove it mathematically, sure, go ahead and look and count to verify it. You certainly don't want to do some incorrect math here and then just move on, even though you could have verified that, oh, okay, well, it wasn't -4 minus -1 wasn't 5, because I can count here and see that it was 3. Let me check my work. So certainly use counting and your brain to verify your answers, but start by proving it mathematically. All right, here comes the big one. What happens if we need to find a diagonal length? For example, segment EF is going to be a diagonal segment. In order to do that, we either need to use the distance formula or we need to use Pythagorean theorem. And as it turns out, they're actually the exact same thing. So if you have some experience using Pythagorean theorem, let me show you how we can turn it into the distance formula. If I just reorder my Pythagorean theorem to say c squared equals a squared plus b squared, just put everything on the opposite side, then we're going to be able to play around and substitute some values here. So let's go back to our diagram. Let's make a right triangle out of this. Doesn't matter if you want your triangle to be positioned like that or if you want to flip it so that it's upside down over here. Works just the same. That segment now has turned into the hypotenuse of the right triangle, or the c value in our Pythagorean theorem. We know how to find the horizontal length on that triangle. We just did a horizontal length at the beginning. We know that we subtract our x values. So to find our a value, it actually becomes x2 minus x1. So instead of a, we'll replace it with that subtraction formula we just used on the beginning. Then we talked about how to find a vertical length. So here's another vertical length. To find the length of b, we're going to subtract the y values right here on this length. So instead of b, we're going to substitute that with y2 minus y1. Now here's a slight jump. We don't have the absolute value bars here anymore because the absolute value bars were helping make this subtraction positive. But here we have a different way of doing it. Because we're going to be squaring this value, squaring will make a negative value positive as well. So we replace the absolute value bars and the square will take its place. So we can just replace those with parentheses, square whatever value we get here, and that'll ensure that we get a positive value out. One more step to turn it into the distance formula. Instead of c squared, we could call it d squared. It doesn't matter what you call this variable right here. But to undo the square, or the exponent of 2, we would square root both sides. And so that's how we get to that final distance formula. It comes from the Pythagorean theorem. All right, let's practice using it. In this first example, we're going to pretend that we place a map below a coordinate plane, or we place a coordinate plane on top of a map so that we can see through it and talk about positions on that map using the coordinate plane. For example, we're going to plot a town Beaverton at -4, 3. So left 4 up 3, put a B for Beaverton. We're going to plot Lake Oswego, another town, at 6, -2, so right 6, down 2. We'll put an L for Lake Oswego. Question is, what is the shortest distance to the nearest 10th? So we'll end up rounding our answer here. What is the shortest distance in miles between those 2 points? Shortest distance is a straight line. So let's not take any roads to get there. Let's either use an airplane or a jetpack. What we can do is we can use our distance formula. We're given the coordinates. So here's my x1, y1 pair. Here's my x2, y2 pair. First in our formula, we're going to subtract the x values for that horizontal length. So -4 minus 6, or 6 minus -4. Remember, it doesn't matter what order. We're going to say plus, and then we're going to substitute our y values. We're going to find that vertical length by subtracting the y values. So 3 minus -2, or -2 minus 3. Again, doesn't matter the order. PEMDAS is going to say to evaluate inside our parentheses first. So let's always work inside out here. So 6 minus -4 comes to +10. And -2 minus 3 inside the other parentheses is -5. Next up, we're going to evaluate our exponents. So 10 squared is 100. 10 times 10. And -5 squared, or -5 times -5, is +25. Common mistake sometimes happens there where we put it as a negative. We got 100 plus 25 now. That's 125. So now we could stop right here. This is the most accurate way to represent that distance. There is a way that we can simplify that square root, but we're not going to do that right now. This is the most accurate way to represent the distance, because if I use my calculator to tell me what the square root of 125 is in decimal form, then it gives me this irrational decimal that continues forever. We don't have enough time in our life to write the entire number value, so what we end up doing is rounding it. Well, if we take a rounded value, that's now an approximation. So the most accurate way to represent a distance is using that radical form. If you can't simplify the square root, just keep it in that form. Or in some cases, as in this example, it does ask us to go to the decimal value and round it to approximate. So ask your calculator what the square root of 125 is. It's approximately 11.18. We're asked to round to the 10th spot. This value of 1 right here is in our 10th decimal spot. So we look to the right. If it's 5 or more, we're going to round up. This is an 8. That's definitely more than 5. So we're going to round 11.1 up to 11.2. And we said our units were in miles. So the distance between those 2 points is approximately 11.2 miles. If you wanted to use the Pythagorean theorem, well, you could just draw a right triangle and now figure out your horizontal length, either using that horizontal distance formula we talked about or counting on a grid. That value is 10, or that length is 10. Find your vertical length, or the side length of that side of the triangle. We can count it or use our vertical distance formula. We can get it to be a value of 5. So we know that 5 squared plus 10 squared equals c squared. So we got 5 squared and 10 squared. The exact same steps we did in our distance formula should give us the exact same answer. One more example here. Go ahead, pause the video and do it on your own, and then check your work. We got 2 points, -3, 4, and 4, 6. So label them. Give x1 and y1 their proper notation, x2, y2. Plug it into our distance formula. Or you could sketch this out, plot it on a coordinate plane, and draw a right triangle. Let's find our horizontal distance, subtract our x values, -3 minus 4, or 4 minus -3. 4 minus -3 gives us 7. Subtract your y values now, find that vertical length. 4 minus 6 or 6 minus 4, doesn't matter. I'm going to use 6 minus 4 and get positive 2 out of it. Next, we're going to use our exponents. So 7 squared, 7 times 7 is 49. 2 squared, or 2 times 2 is 4. Add for our last step here under the radical, 49 plus 4 is 53. We could keep it in radical form and say that the distance between f and g is the square root of 53. Or we could take it to its decimal form and round to the nearest tenth, which is about 7.28. Rounding to the 10th spot, we're going to round up and make it 7.3. So there's how we can use the distance formula. 3 types of segments: horizontal, vertical, or diagonal. In fact, you can use the distance formula for your horizontal or vertical values. It just turns out to be a lot more than what's necessary, since either the horizontal length is the only thing changing or the vertical length is the only thing changing. But feel free to try it out. If you see a horizontal length, try the distance formula. See how it works out the same. Good luck using the distance formula.